Welcome to the course on blockchain. So, in the last few lectures, we have looked into the details of permissionless blockchain settings, where we have looked into the architecture and system internals of a Bitcoin based protocol, and we have went through the details of how a Bitcoin based system works, and what are the different design internals of a Bitcoin based architecture, where blockchain has been used as a fundamental building block. So, the Bitcoin type of blockchain network that we have learned till now, it uses a model which we call as the permissionless model. So, in that permissionless model setting, ideally what happens that every node can join in the network anytime without having any pre-authentication or pre-authorization mechanism. It is like that anyone can join in the network anytime without going through an authentication procedure, and that is why we had a settings in permissionless blockchain where you would require a consensus among the nodes, but that kind of consensus we cannot use the conventional distributed system protocols, and we went through a challenge response based method where the network has thrown certain challenge to the users or the nodes in the blockchain, and then the users have collectively tried to solve a problem, and the node which wins to find out the solution for that challenge, that particular node ensures or advertise the updated blockchain to its neighbor. In contrast to that permissionless setting, where it is more like an open environment, we have another kind of initiative from the industries specifically, which we call as the blockchain 2, and in that particular settings, industry was more focused towards the blockchain application or towards the application of public ledgers, where you have certain number of nodes which is a kind of closed environment. So, the nodes which knows each other, and they tries to come to a common platform where there is no such centralized database or data server. Rather, you still want a complete decentralized architecture, but the difference is that now rather than having a complete open environment, you have a closed environment. So, you have a set of nodes which knows each other a priori, but they may not trust each other. So, that particular settings we call it as a permissioned environment in contrast to a permissionless environment, where nodes cannot join to the blockchain network anytime. Rather, before joining to the blockchain network, they have to go through some authentication or pre-authorization mechanism through which they can validate themselves. So, in this particular lecture series, so in the next couple of hours, we will look into the details of this permission blockchain environment and the different aspects inside it. So, as we have mentioned that a permission model is something where the blockchain architecture, inside the blockchain architecture, the users are authenticated a priori. In that particular settings, the users know each other, but they may not trust each other. It may happen that certain nodes in the network, in the blockchain network, although they got pre-authenticated, they are authenticated to use the system, but they have started behaving maliciously. A typical use case you can think about a certain business environment where you want to go for a business with a set of different levels of users. Now, in a think of a scenario of a typical organization or a typical company in an industry, where in the company every user is authenticated, every user knows each other, or at least there is certain database where you have the records of the users who belongs to that particular company, but that does not prevent the users to behave maliciously. So, the users can behave maliciously anytime, they can make some kind of cheating or fraud with the entire system, and under that particular scenario, we have an architecture where the users are pre-authenticated, the user knows each other, but they may not trust each other because some users can behave maliciously. So, here our objective is to run the blockchain among this known and identified set of participants. So, let us look into certain use cases of this permissioned environment. One interesting use case of permissioned environment is for business application, where you want to execute certain contracts among a closed set of participants. So, earlier we have looked into the details of this concept of smart contracts, where rather than having the contracts on paper, you write down the contracts in the form of a code, and that code will be offloaded to a blockchain environment where the code will get executed. That is a typical scenario of a permission blockchain environment. So, one interesting use case of this can be like this provenance tracking of assets. So, in this provenance tracking of assets, so what you want to do, you want to ensure that whenever certain asset is moving from say one particular suppliers to the distributors to a vendor to and going to the market, at every stage there is certain logs which are being maintained, and inside that log you make an entry that this particular asset has now moved from location A to location B. Now, the interesting fact is that why do not we want to use a centralized server to have this entire log of data, and then anyone can just look into that central log and can verify it. Indeed, nowadays we use that kind of architecture. So, for example, whenever you are sending certain courier service via say Blue Dart or DHT or any kind of courier platform, what you normally do that whenever your letter or your courier is moving from one particular location to another particular location, the courier agency, they are making an entry to their central database that well, this particular location, say the location A, the center at location A has received the parcel, and they have verified the parcel, and then they have verified the send the parcel to say location B, the courier agent at location B. Now, whenever it is moving from one agent to another agent at different location across the entire path from the source to destination, every individual agent is making an entry to their central database. Now, everyone else in that Blue Dart or DHT, they can look into that log and they can find out that where that particular asset is moving or how that asset is moving from the user, one user to the destination or to the final recipient. Now, in this entire architecture, the users are also in the loop. So, whenever you want, you can make a login to their Blue Dart website, or you can provide a reference number or what they call as the waybill number, and through that waybill number you can track that where your parcel is currently located at and what is the expected time that it will reach at the destination. Now, within this kind of centralized architecture, whenever the entire thing is under control of Blue Dart, it is good to use a centralized server because the centralized server is maintained by Blue Dart. But think of a typical scenario when the particular thing is moving from one say courier company to another courier company and a third courier company. So, a typical use case can be like you are sending a postal mail from say India to somewhere in USA. So, whenever you are sending a postal mail to India to somewhere in the USA, so the India Post, they are one authoritative domain, and India Post will basically do the transfer of the post up to their border gateway or the border point. From there, they will send it to some international agency or some international courier transfer, postal transfer, who will then take the mail or take the courier to your USA Post, and then USA Post will do it, transfer it internally. Now, in this entire process, you have multiple authorities who take care of your parcel, but whenever you have this kind of multiple authorities, it is difficult or there is a kind of trust issues whenever you are going to rely on a centralized server. So, the question that comes, first of all, who will host that server? If you want that, well, India Post will host the server, then the question comes that why USA Post will trust or believe the data which is there in the India server. And also the USA Postal, they have to have an access to the central database which is being maintained by the India Post. So, because they have different kind of policies or different kind of environment, it becomes difficult to handle this kind of multi-authoritative scenario when you have multiple authoritative domains and they try to put the information to a central database. Now, the second problem comes like if none of the India Post or USA Post will host that particular database, central database, rather they may purchase the database from some third party agent, like they may think of that, well, we will now host these things to a central database which will be hosted by a third party cloud. Now, if they host it on a third party cloud, then the question comes like you have to pay a significant amount of money for that third party cloud. The second thing is that because there are multiple parties, multiple authoritative domains, they require certain kind of access to that central server, and the question comes that how will you guarantee that the data which is entered by the USA agent or entered by the USA Post that is not getting tampered by the data which is being entered by India Post or vice versa. So, whenever there is this kind of multiple authoritative domains in the loop, you have this kind of problems in trust relationship, and that is why people do not want to go for any kind of centralized server. Nowadays, if you want to send something from India Post to USA Post or vice versa, what you have to do, like whenever the data or whenever your parcel is within India, you can log in or you can look into the India Post website to look into the tracking details, and then whenever it is going to US Post, you have to look into the US Post website to go to the details of the tracking. Now, the information that is shared by India Post to USA Post or vice versa, that will only give you some insight or a kind of partial information like how your asset or your post is moving, your parcel is moving from India to USA or coming to India from USA. Now, for this kind of provenance tracking of assets, we are interested to use a blockchain environment, and the beauty of the blockchain environment is that you do not require any kind of centralized server to be hosted. The data need not to be in a centralized server, the data would be in the individual hand of India Post and USA Post, but everyone will be able to validate others' data. So, that is a typical use case of permission blockchain environment, where you know that well the use cases are going to be the India Post or going to be the USA Post. So, you have a close set of participants who are participating in the entire blockchain environment, but it is like that there is still the trust relationship is not there, and so you have to maintain certain kind of security, or you have to ensure that the data is not getting tampered while transferring from one authoritative domain to another authoritative domain. So, the similar case happens whenever you are transferring certain kind of goods between the suppliers and the distributors. So, you have multiple suppliers, multiple distributors and multiple vendors. Now, it is like that every individual supplier, distributor or vendor, they are individual authoritative domain, they have their own policy of entering data, but a third party auditor should have access to this entire data, and they should be able to reliably verify that whatever data is being passed through supplier, distributor, vendor and the final market, those data are indeed the correct data. To ensure this kind of environment in a distributed setting, we want a permission model, or we want to use a permission model. Now, well, one point here is like you can always use a permissionless model for this kind of settings, but there are certain disadvantages of using a permissionless model, because you are going for an open environment, and whenever you are going for an open environment, your network or your system becomes more complex and you have to handle a lot of things altogether, and that is why we want to move from a permissionless model to a permission model. So, we will look into the certain aspects of a permission model in details. Well, in respect to this permission model, earlier we have briefly looked into the concept of smart contracts. Here let us go to the little details of this concept of smart contract. So, as we have discussed earlier, that a smart contract is a self executing contract in which the terms of agreement between the buyer and the seller is directly written into the lines of code. So, it is like that you are not using a pen and paper to write down the contract, rather the entire contract is written inside the code. So, the question comes that how this kind of contract may get executed, or how a blockchain can help you to execute this type of contracts. So, if you remember the concept of Bitcoin scripts that we discussed earlier. So, a Bitcoin script is certain thing or certain small code through which you can change the control on how the money that is you are transferring to your friend that will be spent later on. By writing into the Bitcoin script, by writing the rules into the Bitcoin script, if you remember, we had this input script and the output script, and our task would be to map the output of the previous transaction to the input of the next transaction, which will give you an idea, or which will give you an verifiable way of finding out that how the Bitcoin that you are transferring to your friend, or how the Bitcoin that you are transferring to your client that is going to be used later on. So, you can write a script where your friend can use that money immediately, or at the same time we have seen that you can write a script inside Bitcoin where you can prevent your friend to use that money for 2 months. It is just like that, once this 2-month pipeline duration gets over, your friend will be able to use that particular Bitcoin for further transactions. Now, in case of smart contract, we actually expand this idea further, where it is not like that some small simple scripts which are being used by Bitcoin. Rather, we detail that script through some programming language or some general purpose programming language. So, you can execute complex type of contracts, like if certain conditions are met, then only this particular Bitcoin will be spendable. So, if your friend meets certain condition, or if some environmental condition that can comes from the other third parties, they gets validated or they met, only during that time the contract will get executed and it will be used further, or the money can be used further after all these conditions get verified. So, the concept of smart contract comes from this fact, like you can extend those simple script which is used in Bitcoin to ensure the execution of smart contract. One typical example is that you execute a transaction when certain condition is satisfied. So, you have a seller, you have a buyer, and you have certain assets, and the contract makes a match with the buyer and the seller. Now, whenever you are buying something, there are certain scripts that will be executed at the seller side, and there will be certain scripts that will be executed at the buyer side. So, whenever someone is selling something, they have a contract like, if I get this much amount of money, then I can transfer the asset from myself to you. And the buyer, the idea is that the moment I have transferred this much of money, the asset should be in my hand within certain duration. So, you can write a contract to ensure this kind of environment. So, it is like that, the moment the buyer transfers the money to the seller, so the moment the buyer transfers the money to the seller, the ownership of the asset goes from the seller to the buyer, and the code that you have written, that particular code actually validate whether the buyer has transferred that certain amount of money. In general, you can think of in terms of Bitcoin or any kind of digital currency. It is like that, the buyer, the moment the buyer has sent that certain amount of currency to the seller, and the contract actually verifies that, well, this amount of money has been transferred from the buyer to the seller, and then it sends the ownership of that particular asset from the seller to the buyer. So, the seller will not be able to claim the ownership on that asset any further, whereas the buyer will be able to claim his or her ownership on that particular asset. So, that is the concept of smart contract, which we can execute in a closed environment with the help of a blockchain. So, here the fact is that in a typical business platform, you have fixed number of sellers or fixed number of buyers, or you can say that there are limited numbers of buyers and sellers in the market, and the buyers and sellers can always register to a central portal, so that everyone can know each other. So, we are making an insurance that everyone knows each other, the buyer knows seller and the seller knows buyers, but there may not be any trust relationship between them. It may happen that some seller is fraud, and that seller it is just taking the money and not giving the asset to you. So, that kind of fraud or that kind of malicious activities in the system we want to prevent with the help of a permission blockchain. So, well, let us look into many of the design limitations which are there in a permissioned environment. So, if you look into the blockchain concept, which actually comes from this typical permissionless environment like a Bitcoin type of examples, there one issue is that we execute the transaction sequentially based on the consensus. So, it is like that if certain transaction, if it gets verified or if it gets committed in one transaction, that will first execute it, and the transaction that is committed later on, that will be executed next. So, the request to the applications here are the smart contracts, they are ordered by the order of the consensus, in which the individual application or the individual contracts get a consensus, and they are executed in that particular order. So, this kind of sequential order actually gives a bound on the effective throughput, because you want to ensure that certain consensus or certain ordering of transactions are made. We apply that proof of work based techniques in case of your permissionless model, where the network or the system throws a challenge to the users, individual users, and every user tries to solve that particular challenge individually, and the nature of the challenge is such that it is difficult to find out a solution for that challenge, but once a solution is found, everyone can verify it very easily. So, with that particular challenge response based method, the nodes try to come to a consensus, but as we have seen, like the challenge is very hard, or the challenge is taking certain time to get a solution, and that is the reason that if you want to this kind of serializable order of transactions execution, you get a bound on the effective throughput. So, ideally the throughput is inversely proportional to the commitment latency. So, it is like that if your commitment latency gets increased, your throughput will get decreased. So, it is like that in a permissionless environment, in a Bitcoin type of environment, if you increase the difficulty of your challenge, if you increase the complexity of your challenge, the effective throughput that you will get, the throughput here in terms of number of transactions that can be committed per second or per unit time. So, the effective throughput that you will get, it will drop in inversely proportional to the commitment latency. So, this can be a possible attack on the smart contract platform. So, you introduce contract, an attacker can introduce contract which will take long time to execute, and that is why if certain contract takes a huge time to execute, the other contracts will not be able to execute any further, because once the consensus for the previous contract has been reached, then only you will be able to execute the contracts which had been submitted later on. So, you maintain a kind of serializability order of the transactions, which is here preventing you to execute the latter contract until the previous contract gets executed. So, if you introduce a malicious contract in the system which will take a huge amount for execution, you will be able to kind of launch a kind of denial of service attack on your consensus algorithm. So, that is the kind of first problem. The second problem is like the implementation of your smart contract. Now, as I have mentioned, to implement a smart contract, you need to go to some language which will give you more power compared to Bitcoin script. So, if you remember that Bitcoin script is not Turing complete language, and because it is not Turing complete, it does not support all the constructs which can be there. For example, it does not support loops, or it has certain limitations in execution. But to implement a smart contract, because you want to increase the power of that particular script, so that you can write down any general purpose contract in the form of a code, we use different kind of language for that. So, the developers have developed different types of languages. So, one interesting language is that Golang, which is widely used in this kind of contract execution platform. So, this is a typical example of a contract execution platform. In case of this Golang, you have a construct called a map. So, map is a data structure where you have certain keys and you have certain values. So, every value is associated with one key. Now, if you run a loop, so here I have defined a map with the string values, the key and the corresponding value, and this map is stored in a map variable m in Golang language, and then we are just writing a for loop on top of this map. So, whenever you have written a for loop over a map and just printing the key value pair, and if you run this code multiple times and you have multiple key value pairs in your map, you will see that at different run the ordering of that key value pairs are different. Now, this gives a non-deterministic execution of certain programming construct which are there in your general purpose programming languages. So, here in the Golang, in the map data structure, that it is designed in certain way, so that it is not necessary like every key is ordered in certain way. So, it uses its internal contracts to fetch the key, fetch certain key and the corresponding value which is associated with that key. So, that is why in different runs you may have different ordering of the keys. So, the smart contract execution, in contrary, it should always needs to be deterministic, otherwise it may happen that the system may lead to certain inconsistent state, or you may have many forks in the system. So, one particular user, it executes the contract, get one result or one ordering of result, another contract it may get another ordering of results. So, if you are getting two different ordering of results, then it may be difficult for you to ensure that that you have the longest chain in the blockchain. Although by the use of the blockchain technology you may be able to ensure that, but you will have multiple unnecessary fork in the system which you want to prevent. So, the solution here is to go for a specific domain specific language which will implement your smart contract platform. So, for example, Ethereum is a platform where you can implement smart contract with the construct that they have supported. Now, the third design limitation is the execution of smart contracts. So, generally we execute the smart contract at all node and propagate the state to others. So, that way we try to reach in a consensus. So, here the consensus is mean that you execute this contract and based on the input you get certain states and ensure that the states which have been propagated to all the nodes in your blockchain environment, they get the same states. But to ensure consensus, the problem that comes that do you have sufficient number of trusted nodes to validate the execution of smart contracts. If it happens that well, your number of trusted nodes are less than the number of malicious nodes, they may get controlled over the entire environment. But you can prevent that by going to a permissionless setting like a proof of work based consensus mechanism, but in a proof of work based consensus mechanism the problem is like you may be able to struck to a particular live lock or a kind of starvation scenario where a contract is taking long time to execute and all the contracts are getting backlogged. So, that is why in case of this permission setting we want to move from that challenge response based method to the traditional distributed system based consensus algorithms. But in that case you have to ensure that you have sufficient number of trusted nodes in the system. So, one interesting question that comes regarding the consensus of permission blockchain model, that do you always need or do you really need to execute the contracts at each node? Indeed, it is not necessary, you just need state synchronization across all the nodes. So, it is like that you execute the contract in one node, then after executing the contract in one node, you propagate the state of the contract to your neighboring node, and that states get further propagated. So, that way every nodes in the system, it get the same states of the contract, and they can be on the same page of your smart contract. But a typical question comes that what if the node that execute the contract, it becomes faulty. So, what if these particular nodes become faulty? Now, if this node becomes faulty, then the system gets down and the systems will not be able to make any progress further. So, in this particular scenario, the idea is that you use the concept of state machine replication. So, you execute the contract at a subset of node rather than a single node. So, you have multiple nodes which can be selected to run the particular contract. So, here these 3 nodes are executing the contract, and the result of the 3 nodes are propagated to all other nodes in the network. So, that way you can ensure a kind of, so through this state machine replication you can ensure that that every node who are they are the part of the smart contract, they are on the same page and they knows that well up to this much of the contract that got executed and the remaining part need to be executed. So, today we will stop at this point. In the next class we will look into this concept of state machine replication, which is a powerful tool to ensure consensus in a permission blockchain environment. So, we will come back next in the next lecture with this concept of state machine replication. Thank you.